All right, so we've talked about the difference between linear and nonlinear. Let's go ahead. Hopefully we can go through this fairly quickly and allow you time to work. Does table A represent a linear or a non-linear function? Is it linear or nonlinear? And you got to be able to explain the difference or why you think it. Cadence. Linear. Why?
Because there's like a constant rate of change on the x and y.
Good. A is linear. What about B? Is B going to be linear or nonlinear? Tyler? Nonlinear. Why? Do what, bud?
The bottom is going up by more.
Is the bottom got a constant rate of change?
Yeah.
Look at it.
No.
No, it is not. The X values did, but the Y values don't. Both values have to have that constant rate of change. Okay? So, no, it does not have, and these are the reasons. Not constant. Not a constant rate of change. That's what you're looking for. Linear compared to nonlinear. Okay? Look at number 1. And I'm not even going to ask you right now to graph it. Look at number 1 though. Is number 1 going to be linear or nonlinear? Linear or nonlinear? Ty?
Linear.
Ty says linear. How do you know it, Ty?
Because there's a constant rate of change on x and y.
Okay, what's our rate of change on the x's?
1.
Okay, so we've got +1 on x. Okay, what about the y?
-2.
-2, good. Good. What about number 2? Linear or nonlinear? Linear or nonlinear? I heard you, Justin.
Yeah,
And you said what?
nonlinear.
Nonlinear. What makes it nonlinear?
It doesn't have a constant rate of change on the y-axis.
There we go. Y is not constant. If I go from 3 to 5, I've added 2. 5 to 8, I'm adding 3. 8 to 12, I'm adding 4. Okay? What about the third one? What's the third one going to be? Linear or nonlinear? Ridley.
Nonlinear.
Nonlinear. What's making it nonlinear?
The y.
The y? Ooh. Yeah, because we've added 5 here, subtracted 5. No, we added 10, sorry. You're right. Subtracted 5, added 10. And if it followed that pattern, the next one I would think would probably subtract 5, but I don't know that to be certain, do I? Okay? If I graph this one, this number 3, what's it going to look like? What's it going to be? It's just going to be that zigzag thing, isn't it? Okay? So it's definitely not going to be a linear function. Two graphs. Which one is linear? Which one is linear, Natalie? B. Linear. Why? Why? Constant rate of change. Good. A is very obviously not a line, is it? Looks Looks like we're going traveling, doesn't it? Okay, so this A is definitely non-linear. Got a picture. Now, we've got to be able to tell the difference between whether we have a graph or a table. We've got to know the difference. It's easy to see it on number 3. Is number 3 a linear equation? No way. It's easy to see. So this one's non. What about tables 1 and 2? Are they linear? Glenn, number 1 is linear? How do you know that, Glenn?
Because the y is a constant
Rate of change on the y is subtracting 5 every time. What about the x?
Multiplied by, or plus 8.
Good. Okay. What about number 2? Is number 2 linear or non-linear? Olivia? Linear, she says, okay? X's, our constant rate of change on the x's is what? Up to. What about the y's? -4 every time. Good. How do you feel about comparing linear and non-linear if you have a table? Thumbs up, you got this, thumbs down. Or somewhere in between. What about on the visual? Which one do you like better, visual or the table? Visual for sure. That's kind of a given. All right, think back. How do you know if an equation of a line is linear or non-linear? How do you know if an equation of a line is linear or non-linear? It's the same thing. Constant rate of change. This is what I've been trying to get you guys to understand, is that what we did in chapter 5, which was our linear equations, is absolutely no different than linear functions. Absolutely no different at all. It's the same kind of stuff. Which is, I guess I just kind of answered that other part. You know it is the equation of a function is linear or non-linear for the same reason. Constant rate of change. So it's like we did chapter 5 and now we're doing chapter 6 and it's 5 all over again. Okay, and that's the way you really need to process this, because it makes it so much easier. Which equation represents a non-linear function? You've been given 4. You figure it out. Are you sure? Does that number change? Could it? Which equation is non-linear? Let me ask you this, would the graph of y equals 4.7 be linear? Yeah. Sure would. Would the graph of y equals pi x be linear? Okay, Shelby, you say yes. Why? It wasn't you. Who said it? Natalie. Why? I'm not saying you're wrong. Tell me why. Can I have a slope of 3.14? Sure I could. Nothing wrong with that. Y equals mx, that's in that formula. M just happens to be pi. Doesn't change the fact that it's still in the slope formula, and it's always that pi is multiplied by x every single time, so that rate of change is going to be exactly the same. Do you agree? What about y equals 4 divided by x? Is it a constant rate of change? Could I pick x to be 2? Could pick X to be 500. Is that rate of change gonna be the same every time? No, it won't. It will not, because it doesn't fit the formula. This is the same thing as saying y equals 4 times 1 over x. That's not where x is in y equals mx plus b, is it? That doesn't fit the formula, does it? And if you've got a calculator, which I don't know that very many of you picked one up, what is 4 divided by, well, let's do the easy one. What's 4 divided by 2?
2.
What's 4 divided by 5? 0.8. What's 4 divided by 29?
0.138.
Is that a constant rate of change? No way, no how. This is non-linear. Y equals 4x minus 1. Is that linear? If I simplify this one, isn't it nothing more than y equals 4x minus 4? Is that still a constant rate of change? Sure it is. X is always multiplied by 4 and then subtracted by 4. But the change is the same. Okay? The only one that did not represent a linear function was C. Okay? It's the only one that doesn't fit. Account A earns simple interest. Account B earns compound interest. The table shows the balances for 5 years. Graph the data and compare the graphs. Let's throw a table out.
We need to get back to
What if you, can you turn your, we don't have whiteboard, so yes, you need graph paper. Gotta try to find it out. Mm-hmm.
We need more copies.
Well, there's other paper over there that may not be the little ones, so just get a big piece. We're just needing to do this one right now. Mm. I know, but surely we got enough that we can work with. That way we can just keep going and you could get time to work on stuff. Okay? Alright, so I have a graph of A and a graph of B. Which one do we want to make our X value? Is it the years or the dollar amount? I would say the years, I agree. So if I go in here and I number this, let me make that bigger. There we go. This is years. Okay, and we're going up, what's gonna make probably by a 110 each time? Is that about the way you guys wanna do it? Be about the best, wouldn't it? Starting at 100. Yeah. So if I go with 100, 140, 160, 180. Will that work? Okay, and this is dollars. Account balance. Okay, so it wants us to graph it. At 0, I had 100 to start with. Okay, first one I went up, after 1 year I have 110. 10. The second year I had 120. Third year I've got 130. Can I graph that now? I've got plenty there, so I should be able to go ahead and draw my line. Okay. And there's my first one. I'm not putting a bunch of those on there because I just don't have enough space. Okay, the second one, we started out the same, and then we went to 110, so the second one was same. But then the next one is 121, so that's going to be just at 2 years I had 121. So I'm starting to come off, and this I'm not going to be able to show it up here on this one very well. And then I go to 133, 146. What are you going to notice about the two lines? Are they going to remain constant as far as the same? It's going to eventually start taking off, isn't it? Okay, we've got it graphed. This is 3 and 133. Close enough. All right. If they continue at the rate that they are, let's see what it is they want us to be able to answer. Oh, stop it. Okay. The table shows the balances for 5 years. Graph the data and compare the graphs. What do you notice about A and B? What do you notice about the graphs? Compare the graphs. Hi. I'm good. How are you?
I'm good.
What are you doing, Miss Bailey?
I'm about to go make copies.
She said Miss Rachel doesn't write
How are you?
minutes off.
Good. How are you doing?
I'm gonna graduate in 23 days. So.
23 days to graduation.
She's not
Heck
counting.
yeah.
But who's counting, right?
How many days till we gotta graduate?
About now.
What are you going to do then, Bailey?
I'm gonna go to Coffeyville through the machining program and get my certificate over there and go on the road.
And go on the road. You don't use any math in what you're going to be doing, are you?
Yeah, you do. You have to learn how to read mics and VCs and certain measurements.
If I remember right, you hated math.
I do. I still do, but gotta do it.
Amazing. Yeah, I like
That's
that.
gonna be us.
Yes, sir. It is going to be you in about 4 years.
You will need it.
Especially nowadays with the CNCs, you have to know graphing. Like, hands down, you have to know, or you can't do the job.
That's awesome. That's awesome. Hey, thanks for coming in. Perfect timing. Considering what we're doing,
Yeah. it is.
perfect timing. It's good to see you, Bailey.
It was good to see you too.
Bye. All right, so tell me about the graphs. What do you notice? What do you notice, Lindsay?
Count B is gonna make more.
Account B is going to make more, okay, with the, what we call the compound interest versus the simple interest, okay? Do you know the difference between compound and simple interest? Simple interest says you earn 25% interest per year. That's it, 25 per year, okay? Compound interest, oftentimes a compound interest is like 25% per quarter. And so at the end of the first quarter, if you had $100, let's make this even easier. At the end of the first quarter, if you had $100 and you had 10% compound interest, what would you have at the end of the first quarter? Do you know? $110. At the end of the second quarter, you're going to earn another 10% interest. How much will you have then? You have 110 going into the second quarter. Now at the end of that second quarter, you got $110. How much money do you have? What's your interest earned going to be?
120.
I'll go more than that. Now I have $110, and 10% of 100 is 10, but 10% of $10 is 1. So there you go. Now I have the $121. Okay, I didn't even realize that, but yeah, that is. Okay, And then at the third quarter, you get 10% of that. You see how it keeps changing, it keeps going up. That's why you're making more money on a compound interest versus simple interest. If you go to borrow money though at the bank and you want to pay a loan back off, which type of interest do you think you want? Simple. Because otherwise what you have to pay back can change, okay? And sometimes, but now if you think about it though, if you're paying money back and if each month you're paying it off, then does the interest decrease?
I guess.
It would, wouldn't it? Because now you have a less amount that it's going to figure the interest on. So that would be nice for compound. Okay? Just some things to think about. And someday y'all are going to be having loans for vehicles, and you're going to want to be able to pay them off. Okay? Let's go back to, I don't know if I can do it from there. Go back to where we were. Okay, take a look at it. Does equation 4, give me thumbs up, yes, thumbs down. Thumbs up is linear, down is nonlinear. Is equation 4 going to be a linear equation or a nonlinear equation? Showdown. Good, I see thumbs up. So this would be, this is linear. Why? Why? Why is it linear? Olivia? Okay, what's your rate of change there? 1, good. Number 5, linear or nonlinear? Y equals 4x divided by 3. Linear or nonlinear? Don't let this one trick you. This one,
Wait. Because X is
this one is actually linear. Because I could write it this way. Y equals 4 thirds times x. Do you agree? Because x is over y. Okay, so technically this one is linear. Okay, what about number 6? Is number 6 linear or nonlinear? Austin, what do you think?
Non-linear.
Nonlinear, why? You are right, why?
Because x has to be by number 1.
X has to have an exponent of 1. It can't be x to the second power. The minute you see x to the second power, it's nonlinear. Yes. X to the second power says that the square root of x would be a positive and a negative number. Because, okay, 4, if x was 2 to the second power, it would equal 4. Do you agree? If x was negative 2 to the second power, it would also equal 4. Therefore, that x value could be a 2 or a negative 2. That's where you get the parabolas, like the one we saw a little while ago that had the, look like a V, okay? So, that one is nonlinear. How do you feel about comparing linear and nonlinear with what we've been doing? Fist to 5, show me. Okay, that's what you're going to be doing, all right? Math Journal, page 136, and then textbook, page 271, 19 to 21. And we will be switching at 9:55, so you have 24 minutes. No, 9:55 I said, sorry about that. You have 19 minutes, all right? But that still gives you some time to work.